Hello. Can all of you hear me? Am I audible? Can someone just confirm? Am I audible? Let's begin. To begin with, I'm wishing you all a very happy Independence Day. I hope you had a great day. So let's start. So welcome to week 3 of Aircraft Stability and Control. I am Tanya. I'm one of the TAs assigned to the post taught by Professor A.K. Ghosh. So we'll go over the contents of week 3. Before that, we'll just discuss the questions of assignment 1 and assignment 2. You've all done the 2 assignments, right? I hope it went smoothly, but we'll just discuss the questions just in case. Okay, so let's start. Yeah, the first question of assignment 1 was an aircraft with aerodynamic center forward of aircraft center of gravity is statically stable, statically unstable, neutral, should be neutrally stable, or none of these. Aerodynamic center ahead of the CG. Statically unstable. Yes. Why? Can you tell me why? You're right. B is the right answer. Statically unstable. Why? Yeah, I'm glad the can is catching on, but just to elaborate. So if this is your fuselage reference line, and this is the AC, this is the CG. If the aircraft is subject to a gust, it gets pushed up, and the force is generated at the aerodynamic center, that is the lift and drag. So if there is a gust, something like this, so there is a delta alpha, and the lift generated at the aerodynamic center continues to produce a disturbing moment. Okay, there is no restoring moment. Moment is not restorative. Correct. Yes. So at the same time, if this is the CG, and this is the AC, if there is a similar gust, delta alpha, the lift generated at the AC will provide a restoring moment. Okay, so it will be inherently stable. So it shows a tendency to come towards your equilibrium point. Okay, which is why if your AC is ahead of the CG, it is statically unstable. Okay, next. For a neutrally stable aircraft, the value of Cm alpha is dCm upon d alpha. So what is the value for a neutrally stable aircraft? We've all done the assignments. It's fairly simple. Can just one of you just tell me for a neutrally stable aircraft, Cm alpha is 0. Exactly. For a stable aircraft, it should be, what should it be for a statically stable aircraft?
Positive.
For a statically stable aircraft,
Negative. Trim should be positive.
yes, exactly. It should be negative. So this is the only condition required for static stability, static longitudinal stability, where Cm alpha should be less than 0. Okay, that is the only condition for static longitudinal stability. Okay, so if it's neutrally stable, it's 0. So what happens is if it's subject to a gust, if it's subject to some disturbance, it finds a new equilibrium point at that location and continues to remain there. Okay, if it is statically stable, it tries to come back to its original equilibrium, and if it's statically unstable, it just keeps deviating further. Okay, what do you mean by aerodynamic center of an airfoil? This should be simple. You should be able to get this. We've discussed this many times.
C option.
It's the point at which the pitching moment is independent of angle of attack. Correct, exactly. Just give me a minute. Am I audible now? Am I audible? Okay, thank you. Yeah, so the answer is 3. You are right. Okay, let's go to the next one. The object shown in the following diagram can be considered as statically unstable, statically stable, or neutrally stable. We had discussed this initially when I introduced stability. I think even Sir has discussed this. Be statically stable. So yeah, initially the ball is at this location. You deviate it. It has a tendency to come back to its equilibrium point. Okay. And the other two cases were this is statically stable. For statically unstable, you had something like this. The ball is here. You deviate it slightly. You just keep deviating from the equilibrium point. For neutrally stable, it's something like this. So if you deviate it, it goes here and it forms a new equilibrium point. All right. What does an elevator do? So elevator is a control surface in which direction? Like what angle does it control? Yaw, roll, pitch. What does it generate? Pitch, correct. So it generates pitch. What are the other control surfaces? Elevator generates pitch. What generates roll? What generates roll? Aileron, correct. And yaw? Rudder, correct. For a symmetric airfoil, CL naught is positive, negative, 0, or none of these. What is it? 0, yes. So for a symmetric airfoil, the curve is something like this. CL versus alpha, this is symmetric. And for a cambered airfoil, it's like this. Okay, so this is for cambered. The next question. For an aircraft having static margin 10%, CM versus CL. Just give me a minute. The audio, there is some problems. Give me a minute. All right, let's continue. For an aircraft having static margin 10%, CM versus CL plot is as shown in the figure below. Find the value of CM naught, that is the pitching moment coefficient, at 0 CL. It's marked in the figure. So how would we proceed with this? So they've given you static margin and they've asked you to find out CM naught. And they've given you a graph. How would we proceed with this? How would we proceed with this? They've given you static margin as 10%. So that's 1. What is static margin? What was static margin?
XCG minus
Static margin was minus DCM by DCL, which was neutral point minus XCG. Correct? Let me know if I'm making some signing mistakes, but as far as I remember, this is the right one. Correct? Okay. So for this question, we only require that the static margin is DCM by minus DCM by DCL. So you have 0.1 is minus DCM by DCL. Can you tell me how to find out the slope of this line from the graph? Take any 2 points and tell me the slope. And use a point that has CM naught. So what is DCM upon DCL? How do you find the slope? How do you find the slope? Y2 minus y1 by x2 minus x1, straight line equation. So what is y2 minus y1 in this case? You all submitted the 2 assignments, right? So how did you do this question? All right, so y2 minus y1, I'm taking this point and this point. These are the 2 points, okay? So Cm naught minus 0 by 0 minus 0.45. Okay, so I just plug in the values and find out Cm naught. What is Cm naught? Just 0.45 into 0.1. 0.005. So in this case, we see that all the options given are positive. Why should Cm naught be positive? Why should Cm naught be positive? I am audible, right? So, can someone tell me why should Cm naught be positive? Trim positive, yes. It is to trim your aircraft at a positive angle of attack. All right, so positive alpha, to trim your aircraft at a positive alpha. So it's just desirable to have your Cm naught positive. It's not a mandatory condition. Okay. Not a mandatory condition for stability. Similar graph for an aircraft, the Cm versus CL plot is shown in the figure below. In this case, they've given you the location of the center of gravity, the neutral point. They've asked you to find out neutral point. So now we use the same static margin equation. What was static margin equation? Is minus dCm upon dCl, which is x bar np minus x bar cg. Again, do let me know if I'm making any sign mistakes. Okay. So how do you find the slope of this line? Similar thing. I'm just taking these 2 points. Can someone tell me what is the slope? You can type it in the chat box if you don't want to unmute. What are the 2 values? It's 0.078 minus 0 by 0 minus 0.65 is x bar np minus x bar cg is 0.28. So what is x bar np? Just calculating, let me know, 0.12. Okay, what was 0.12? The slope, yes. So it will be 0.12 plus 0.28, which is 0.4. Next, the aspect ratio of an elliptical wing is infinite, 0, finite and non-zero, or none of these. See, yes, finite and non-zero. When will it be infinite? When will it be infinite? For an airfoil, yes. Will it ever be 0? Can 0 ever be the case? No, yes, it can never be 0. All right, next. Aspect ratio, we've discussed this question multiple times. As aspect ratio of wing decreases, the lift curve slope will, the slope of the lift curve graph. As the aspect ratio decreases, the lift curve slope will, what is the lift curve slope? CL versus alpha. CL versus alpha, something like this. So as your aspect ratio decreases, how will this graph change? How will the slope of the graph change? How will the slope of the graph change? We've discussed this question multiple times. You've submitted this assignment. Okay. So it will reduce. So this is aspect ratio infinite. So this is something like 15. And it reduces to 10. The slope keeps reducing. Okay. We have dealt with this multiple times. Okay. So this is how the lift curve slope changes when the aspect ratio decreases. So slope decreases. Okay. Now we move on to week 2. So whenever there's such question given, read the data given to you clearly. In this case, I think it was straightforward, but you can have some confusing data given to you. Okay. So let's read the question. The wing fuselage pitching moment characteristics of an airplane is given as minus 0.06, minus 0.0045 alpha, where the alpha of the fuselage reference line is in degrees, or the angle of attack is in degrees. WFS means wing fuselage, straightforward. S wing, area of the wing, span of the wing, mean chord of the wing, XCG upon C bar, aspect ratio of the wing, CL alpha of wing fuselage, CL naught, wing setting angle, and some data for the horizontal tail. Okay, so if I just look at this equation, just considering wing and fuselage, is it stable or unstable? Which one did you want me to explain again? Sandra, which one did you want me to explain again? This one. Okay. So what happens is when you have the infinite, the aspect ratio infinity, which is for airfoil, it is a infinite span wing. Okay. So if I make it finite span, there is some vortices generated at the wing tips. I had mentioned this previously, right? So due to the vortices, why are the vortices generated? The airflow over the upper surface and the lower surface of the wing interact at the wing tips. So if this is the wing, the airflow at the bottom and the top interact at the wing tips. And here you have some vortices generated which do travel downstream. But what happens here is that the amount of lift that the airfoil could have generated is not generated for a wing because of this vortice generation. Okay. So there is the boundary layer separation, there is drag over there. So there is a reduction in the lift that the airfoil could have generated. If it was of infinite span, then it would be generating that much lift. But since it is finite, there are vortices formed at the tip, which reduce the amount of lift generation. So for the same angle of attack, for an airfoil and for a wing, the lift will be different and it will be lesser for a wing, which is why the slope reduces. Okay. Okay. Yeah. So coming back here, if I just see this equation, which is a CM equation for wing and fuselage, right? If I just look at that equation, can you tell me if it's statically stable or unstable? Looking at the values.
Statically stable.
Statically stable. Why? Because your
Negative
CM,
sign.
yes, correct. Because your CM alpha here, the slope is negative. So it is statically stable. Okay. Again, I'm repeating, CM alpha less than 0 is the only condition for static stability, longitudinal static stability. Okay, let's go to the questions. First question is, it is desired to have complete airplane pitching moment characteristics as CM at the CG is 0.17 minus 0.035 alpha. Again, here, is it statically stable or unstable? Again, it's a negative slope. So again, it is statically stable. So obviously, it's desirable to have statically stable. So that is the desired characteristics. And notice here that your CM naught is positive. Initially, it was negative. So if it is just the wing and the fuselage, this aircraft would not be able to trim at a positive angle of attack. Once the tail comes into the picture, you have a positive CM naught, which is one way that we saw how to get CM naught positive, right? How did we get CM naught positive? There were two ways. What were the two ways?
Use of reflexive airfoil or setting wing angle.
Exactly. Use of reflexive airfoil or the wing setting tail angle combination. Can you mute yourself? Okay. So, someone has unmuted themselves. Okay, let's continue. Okay, so here once the tail is introduced, they might have adjusted the tail setting angle such that it leads to a positive CM naught. Okay, two ways for positive CM naught. One was reflex. One was the I wing. Harshit, can you mute yourself? Harshit? Harshit, please mute yourself. Harshit? Okay, let's hope he doesn't make any more noise. Okay, let's continue. So it is desired to be the Harshit?
नहीं आई है ना पूरा गाना तो खराब है नहीं आई है अबे निकली है अबे मौका अभी सुधार करिए अबे सुधार करिए देखो का लास्ट तक अच्छी बना
Harshit? I cannot remove him and I cannot.
उड़ान ना आई हमार देखिए पूरी
Harshit? I hope you guys are able to hear me over this commotion. Let me try. Harshit?
सेकंड चलती है रियल में
Continue. So how do you think we should proceed with this question? What is the contribution of the horizontal tail towards the overall desired characteristics?
बड़े मुश्किल में बाद में वो हमने देता है ना और देर में
Can someone try to answer over this commotion? Someone try to answer this question? How do you proceed with this?
Abraham. Abraham का अच्छी मूवी बनावा था
I am not the admin, so I can't do that.
अजीत साला
Yes, tail plus wing. Just subtract these two desired quantities. Okay. You have CM naught tail is CM naught wing fuselage tail minus the CM naught of wing and fuselage. All right. So what is the CM naught of wing fuselage tail? The overall desired characteristics, that is 0.17. Yes, CM naught of wing fuselage. Oh my God, this is very disturbing. Harshit.
वो ना वरुण धवन ना है वो एरिया में जो है वो मना ही है अब भाई वो क्या है लेकिन वो तापत है वो का नाम होगा मैं मोबाइल के बैठ गरम गरम लाग रहे कहते खुला में जो देता अलग समझो यार
I can't do anything about this. I'm really sorry. Harshit, if you can hear me, please do unmute yourself or leave the meeting. Let's try doing this. Okay, so CM naught of wing and fuselage was minus 0.06. 0.06. What do you get? Final value? Final answer? 0.23. Okay. Let's go to the next question. It is similar question, but for the slope, right? So for the slope, again, just do a similar subtraction. So you have CM alpha of wing, fuselage, tail, the entire thing. That was this minus 0.035. 0.035 minus this value. What is the final answer?
Oh.
Tell me what the final answer is. Yes, this was. Oh, yeah. 0.5. That is B. Okay. Next, the approximate value of d epsilon by d alpha. What is epsilon? Oh God. Harshit. Can I just give all of you another link and you can join that? That would be more convenient. This is very irritating. Will that be fine if I give you another link? Can the rest of you please tell me if that's all right? Okay, so I'll just do that. Okay, he has finally decided to mute himself, so let's continue with that. Harshit, am I audible now? Are you listening to me? Can you hear me, Harshit? I think he has completely muted his audio or whatever. So let's just continue with this. I hope there's no further interference. Okay. So approximate value of d epsilon by d alpha. What is epsilon? What is epsilon? What is epsilon? What is epsilon? Yeah, okay, the value is that, but what is epsilon? What does it signify? What does it represent? What does the value epsilon represent? Why did it come into this derivation? Why did it come into this equation? What is epsilon? What is epsilon? Can't remember. Related to angles. It's obviously related to angles because there's an alpha there. You don't just remember the equations, don't just remember what it is equal to, but what is epsilon? I have said this several times over the last 2 weeks. I think I told about this today also. Somebody else? Can somebody else at least say you don't know if you don't know? Somebody else. You don't remember, just say that. But say something or type it in the chat box. Say something. Thank you. I see that there are only 2 people in this class. Okay, so epsilon is the downwash angle. Did you remember hearing of it? Yes, yes. So what was downwash angle? Because of the vortices generated at the wing. And since your tail is in the wake of the wing, there is a reduction in the angle of attack, reduction in the velocity seen at the tail as opposed to seen at the wing. Okay, so that is the downwash angle. So this epsilon is that downwash angle. Now, yes, you told me the equation correctly, the formula correctly. This is d epsilon by d alpha. And remember that this CL alpha wing should be in per radians. Only then this equation is valid. All right. Okay, so let's try to plug it in. 2 CL alpha of wing. Where is CL alpha of the wing fuselage? You can just take this. So it's 0.07. You convert it to per radians. What do? Multiply it by 57.3 divided by pi. Since I don't think E is given, just assume it to be 1. AR aspect ratio is 6.58. Okay, can you calculate and let me know this? What is the value? What is the value? I don't have a calculator with me. Just calculate. .39. Okay. So if any answer is marked wrong, do let me know. I don't really have a calculator with me right now. So I'm just going with whatever is told to me. All right. 0.39. Okay. Next, the horizontal tail volume ratio, VH. What was the equation for VH? Horizontal tail volume ratio. So the equation was, we had ST upon S, LT upon C bar. Since we don't have these values, we use something else to find out. Okay, so you have just found out CM alpha contribution of the tail. CM alpha contribution of the tail, we remember from the main equation, was this much. So in this equation, you have d epsilon by d alpha, you have CL alpha tail, you have the tail efficiency factor, you have CM alpha tail. All that you don't have is the VH. All right. So now you can find out VH from here. VH is equal to minus CL alpha tail by beta CL alpha tail. Right? And 1 minus, what was d epsilon by d alpha? 0.39. So Cm alpha tail, what was the value? Minus 0.035. Minus 0.0305 by eta is given as 1. Cl alpha tail. Cl alpha of the tail. 0.073. Now your this Cm alpha tail was in per degree and your Cl alpha tail is also in per degree. So you don't have to do any conversion. If both are in the same unit, they will just cancel each other out. Okay. So you don't have to do any conversion. So I'm not multiplying 57.3 anywhere, numerator or denominator. Okay. Into 1 minus 0.39. What is this value? One of you calculate and let me know. Just calculate this quickly and let me know. It's a fairly simple calculation. Minus 0.0305. Divided by 0.073. 0.684. 0.684. This is the closest value, all right? Okay, let's go to the next question. The horizontal tail area to wing area, ST upon S. Just now we saw that the horizontal tail volume ratio was ST upon S by L into LT upon C bar, okay? So we can use that and find out. This is the equation. They've asked you to find out ST upon S. How do you do this? You have VH, right? So ST upon S is VH into C bar by LT. Now C bar is C bar of the wing, okay, mean aerodynamic chord of the wing. VH was, what is the value? 0.684. C bar of the wing is 1.254. What is LT? LT is 4.096. 6. Very simple, just do this calculation, tell me the value. Please, somebody just calculate it and let me know. So you found out VH using the Cm alpha of the tail, and then they've asked you to find out the ratio of tail area to wing area. Can you just find out this value? .209. Okay. 209. That is option 4. Okay. Let's go to the next question. The approximate value of epsilon naught in degrees. So this is again straightforward formula which somebody had told in this chat earlier. So let's just plug in the values and see. Now what is the unit of CL naught? CL alpha was either per degree or per radian. What is CL naught? What is the unit of CL naught? CL naught or CM naught, what is the unit? No unit, exactly, it's unitless. Okay, so yeah, let's try to do that. 2 into CL naught is 0.26 by pi. E is not given, assume it to be 1. Aspect ratio of the wing, 6.58. Okay, what is this value? It's straightforward equation, but there is one change here that they've asked you epsilon naught in degrees. So every time we use these equations, everything is in radians or in per radians. All right. So here what the value that we get, the value of epsilon naught will be in radians. And you need to convert it into degree to see if the answer matches. All right. So can you tell me this value here? 2 into 0.26. 6 divided by 5. So this is 0.02. This is in radians. How do you convert it to degrees? How do you convert it to degrees? How do you convert it to degrees? Multiply with 57.4. All right. So it's just 0.02 into 57.3. 180 by 5. You're right. So it comes to around, this will be something around 1.44, I think. Just correct me if I'm wrong, but I think it's around 1.44 degrees. Okay, is that clear? So every time such questions are asked, be very careful about the units. All of these formulae are in radians. Okay, unless explicitly specified. In this question, it is given that the angle of attack is in degrees. So this is in per degrees. Okay. Otherwise, unless explicitly specified, assume radians and proceed. Okay. And just check what they've asked you in the question. Here they've asked in degrees. So you have to multiply and be careful with the conversion. Okay. It's multiplying by 57.3, multiplying by 180 by pi. Okay. So it's 1.44. Next, calculate the tail incidence angle in degree required to achieve the required CM naught tail. How will you calculate this? Can someone tell me? Given the formula that we already know, how will we calculate this? What is the formula that we can use? You don't have to tell me the whole formula, just give me an idea. We're obviously going to use one of the values that we found out earlier. Which value will we use? We've all submitted this assignment, right? So can you just tell me?
Yes, ma'am.
Yeah, tell me. You don't have to give me the whole formula. Just give me an idea with which we can work. Like which value should we use, and I'll write down the formula, but just tell me. How will we proceed? How did all of you do this? How did you solve it? What was your thought process? What was the one value that we have found out in the previous questions that we can use here? What is it? How did you all solve this? You don't have to give me the whole equation, that's fine. Just try. In fact, that term is given in the slide already. Can you just tell me which one will be used? What value will be used? Downwash. Okay, we will be using the downwash angle, correct? So the equation that the value which we'll be using is CM naught tail. And then we'll use the CM naught tail equation and then proceed, correct? In that, yes, downwash angle is there. That's not wrong. Okay, so this is the equation. CM naught tail is VH eta CL alpha tail into wing setting angle, downwash angle, tail setting angle. And the only value we don't know here is the tail setting angle. Okay, so let's just substitute all the values and try to find this. So I tail is minus CM naught tail by VH eta CL alpha tail plus I wing plus epsilon. Okay, just let me know if I'm making any sign mistakes. So minus CM naught tail was 0.23. One, 2, 3. By VH was, what was VH? 0.684. Theta is 1, CL alpha of tail. CL alpha of tail is 0.073. Now, since your wing setting angle and tail setting angle are in degrees, you can continue with this equation. Okay? And they've asked you the final thing in degrees. So, since everything in the equation is in degrees, you can continue with it. Okay? Plus wing setting angle is 2 degrees. What is the downwash angle? 1.44 plus 1.44 degrees. So what is this value? Can you just calculate and tell me? What is the angle? Can you just tell me what the angle is? I don't have a calculator with me, it's just my phone. So can you just tell me what the angle is? So I'm getting something around minus 1.17. Do correct me if I'm wrong. I don't think it's wrong. Okay, minus 1.17 degrees. You can all just go and look at your previous answers and just tell me. I don't have a calculator with me, so just tell me. Okay, it's okay if it's wrong. It's not an exam. Okay, let's go to the next question. For a conventional aircraft, the sign of CL delta E and CM delta E will respectively be. What is the sign of CL delta E? CL delta E, what is the sign? Okay, but you'll have to explain. Why is it C? What is the sign of CL delta E? What is the sign of CL delta E? What is CL delta E? What is CL delta E? This is not going to work if none of you try. One of you just try. I'm not saying it has to be right. Just try. What is CL delta E? What is CL delta E? What is CL? Okay. And what is delta E? CL is coefficient of lift. Okay. What is delta E? What is delta E? E is downwash. Okay, Sanath, have you watched the videos week 1, week 2? Okay. Did you see something about controls in there? Yes. So now can you tell me what delta E is? What is the control in the longitudinal direction? To generate pitch, we just discussed this in one of the first few questions. What was the control for controlling pitch? Elevator, yes. So what was delta E? Did all of you at least attend the live session last week? I do remember these names, but why don't you remember what E or delta E is? Also, how did you answer this? How did you answer option C if you don't know what delta E is? You can't just remember that this sign is positive, this sign is negative, and then try to go on, because as the weeks progress, you have a lot of such derivatives coming into play. So CL delta E, CM delta E, then ailerons, the rudder, and all of that will come. Okay, so what? Yes, the elevator is the control for the pitch. So now tell me what delta E is. Delta E is just the deflection of the elevator, how much you're deflecting the elevator. How are you answering this question if you do not know that? Please don't just remember the signs now, because now it's just longitudinal and it's just static stability. But when the dynamic stability and the other directions come in, you will have a lot of such control derivatives. And it's going to be very hard to remember. You can't just remember it. You will have to understand what each of them means. Okay, let's just go back to week 2 slides, because this is not working. Give me a minute to find out the slides. Do you remember this slide? Okay, let it load. Okay, do you remember this slide? Do you remember we discussed controls? You remember this graph that I drew? Delta E trim. Yes. Yes, then why don't you remember what delta E was? Delta E is the deflection of the elevator. We had discussed this extensively. How can you not remember? Okay, so delta E is the reflection of elevator. No, you don't have to say sorry, but it's okay. So delta E is the reflection of the elevator. It's a deflection of the control surface in the pitching moment direction, elevator delta E. Okay. So when you deflect your elevator down, like I've drawn here, it changes the camber of the airfoil. When it changes the camber of the airfoil, what happens? Lift is produced. There is a change in the lift produced. Okay. So you have a positive delta L, correct? There's a increase in the lift in the upward direction. Okay. So when I deflect the elevator down, it changes the camber, it increases the camber, produces the lift in the upward direction, and hence your CL delta E. What is CL delta E? Is DCL upon D delta E. So both the numerator and the denominator are positive. Changing delta E gives you a positive. Increasing delta E gives you a positive change in lift. So D delta CL, DCL by D delta E is positive. At the same time, due to this positive lift, there is a pitch down moment created at the CG, correct? There is a negative moment. Pitch down is negative. I've said this multiple times. Pitch down is negative, pitch up is positive. Elevator down is positive. Elevator up is negative. So when I deflect the elevator down, positive lift is generated and negative moment is generated. Yes? Is that clear? Okay, so let's go. Yes, here. So CL delta E is DCL by D delta E. Positive delta E is downward deflection of elevator. It produces positive delta L, which gives you negative delta M. Okay, and here CM delta E is DCM by D delta E. This is positive and this is negative. Do you understand why? When you deflect the elevator down, it produces a positive lift. And that positive lift produces a pitch down moment about your CG, which is negative. Okay. So yes, your answer is right, positive and negative. But you need to know all of these terms because I'm telling you again, there are multiple such derivatives that come into play as the weeks progress. Then it will become difficult. Please don't just try to remember it. Okay. Try to understand what each of them means and just try to visualize what lift or aerodynamic forces it will produce when each of them is deflected. So these are known as the control derivatives. Okay, so CL delta E and CM delta E are known as the control derivatives. Why? They are the derivatives produced due to deflection in the control surface, and the control surface is elevator. Okay, so you don't have to be sorry that you don't remember, but just please, I'm requesting all of you to go back to at least watch the slides or something. It's a summary of what was discussed in the lectures. So just go through the slides once. If there's any question, do put it up on the forum. Okay. Or we'll discuss them in the next class, but do ask and do go through those slides. Okay. So these are known as the control derivatives. What were the other derivatives? That is CL alpha, CM alpha. These are known as the aerodynamic derivatives. Why? Because they are produced due to the aerodynamic motion. Okay. I hope it's clear. And now when the other like rudder and ailerons come into play, you will have other control derivatives, which is when it becomes difficult if you don't understand why it's producing. All right. So just try to understand the physics behind it, not just remember the derivatives. Okay. So here, when I deflect the elevator down, produces positive lift, produces pitch down moment. Hence, CM is negative. All right. Okay. For static stability, minimum condition that must be satisfied is, this we've discussed several times. Can you try to tell me? For static stability, minimum condition. In fact, the only condition that should be satisfied. Yes, Sandra, you're right. It should be less than 0, which is the first case. So I'll just try to tell you why this is the case. Okay, I think we have discussed this again, but let's just for the sake of completion. So, okay, so this is your AC and this is your CG. Now, so if there is a gust, this was the first thing that we discussed initially. So if there is a gust here, you have an delta alpha, and you want to come back to its equilibrium position. But since your AC is here, it will just continue producing disturbing moment. It will not have any restorative moment. So that means in this case, Cm alpha is greater than 0, not stable. In terms of static stability, okay, not stable. So if your CG is ahead, and AC is here, and there is a gust, there is a delta alpha. You have lift forces here, and they produce restorative moment. So in this case, Cm alpha is negative. So what you can see here is for a positive alpha, you need a negative Cm to bring it back to equilibrium, right? Here, this is negative moment. Okay, this is positive moment. This is negative moment, right? Pitch down is negative. Pitch up is positive. Again, how do you come up with these conventions? I remember telling this, but I'll just go over it again. So your pitch axis, your pitch axis, put your thumb along your pitch axis, and the way your fingers curl is the positive moment. So they curl upward, right? So pitch up. So pitch up is positive, pitch down is negative. Is this clear? Is this convention clear? Okay. So you put your thumb along your pitch axis. What is the pitch axis? The longitudinal axis. What is the pitch axis? So the body frame of the aircraft is located at the center of gravity of the aircraft, and you have 3 axes. One is the pitch axis, one is the roll axis, one is the yaw axis. What is the pitch axis? Nose to tail. Okay, if nose to tail is the pitch axis, the motion about nose to tail would be what? Again, I think I had discussed this. Yes, I am waiting. What is MB? All right, but what is the pitch axis? And nose to tail, there is an axis from the nose to tail. What is that axis? The motion about that axis would be what? Again, we've discussed this. I think week 1 we had discussed this. I'm not sure. Week 2. Where did we discuss this? This here. Yes, here. So you have 3 axes. You have the roll axis, pitch axis, and the yaw axis. All right. Located, and this axis system is located with the CG of the aircraft. Now, if you point your thumb towards your pitch axis from CG towards the wing, okay, towards the starboard wing. Okay, so if you put your thumb along your pitch axis, and the direction of your curl of the fingers is the positive pitch, which is in this case pitch up. So pitch up is positive, pitch down is negative. Similarly, for the other axis, you can do it. Okay, right now let's focus on the pitch axis so as to not confuse yourself. But this is what you do. You put your thumb along the axis, and the direction of the curl of the fingers is the positive convention of the moment, of the respective moment. Okay. Okay. Let's go back to our Where were we? Just give me a minute. Yeah. So you need a negative pitching moment to produce a restoring moment. Is that clear? So that is why your slope CM alpha should be negative. Okay. Is that understood? Is this clear? Yes, CM alpha should be negative, but do you understand why it should be negative? Is there any confusion here? We're still at the beginning of this lecture series. So if you have any confusion regarding how or why the sign conventions are such, do let me know. Tell me, do you understand why CM alpha should be negative for a statically stable aircraft? Because for a positive, so CM alpha is dCn by d alpha. So for a positive change in alpha, if this is positive, what moment should you have so that it comes back to equilibrium? Pitch down. So this should be negative. So your overall CM alpha should be less than 0, should be negative. Okay, is this clear? Please tell me if it's clear. Yes, okay, thank you. Then, okay. Which of the following correctly describes the term delta alpha T by delta E? So now E was elevator, delta E is elevator deflection. And what is alpha T? What is alpha T? Angle of attack at tail. Yes. So if I deflect the elevator down, will the angle of attack at tail increase or decrease? So if I take D, sorry. So if I take D alpha tail by D delta E, if I take this as positive, if I deflect the elevator down, will it increase or decrease the angle of attack at the tail? What is the answer to this question? If you have not answered it, at least you would have gone over the answer key, right? So tell me, what is the answer to this question? A, B, C, D. Okay. So that means all of them are true, right? So the value, they say it lies in the range of 0.4 to 0.5, which sir has explained in the videos. You should and must go back to the videos and watch it. But here it says C, the statement C is also true. So it lies in the range 0.4 to 0.5. So what do you think will be the, if I deflect the elevator down, will alpha T be positive or negative? This is your clue. Sorry about that. Coming back to the question, if I deflect the elevator down, will your alpha tail be positive or negative? Just consider point C. What is point C? What do they say? Please, one of you unmute yourself and just tell me, what does point C say? Unmute or type it here, whichever is convenient. So it is represented by tau, right? So it is, all 4 points are true. So now it's D or delta alpha tail by delta E. Is this positive or negative? Is this positive or negative? Positive. So if I deflect the elevator down, will alpha tail be positive or negative? Deflecting elevator down, is it positive or negative? Sign convention. Okay, Harshit, you'll have to tell me negative is for what? What is negative? I've asked multiple questions here and your responses are coming late, so I'm not sure what you're responding to. Deflecting elevator down, is it positive or negative? Sign convention. There's no need to be sorry. Just tell me, if deflecting elevator down, what do you think? Is it positive or negative? This is to all of you. Just somebody tell me, what do you think? Deflection of elevator down, which I had just mentioned a couple of slides before, is it positive or negative? Okay, so deflecting elevator down is positive. Okay, so that is our sign convention. So let me just come back here. Previous slide. Sit. Yeah, so now I told you why the sign convention M is down is negative, right? So similarly, delta E downwards is considered positive. Okay. Delta E downward deflection is considered positive. I think this I had mentioned in the slide again. Delta E downward deflection is positive. So when I say positive delta E, I mean downward deflection of elevator. Downward deflection of elevator, do you think it gives positive or negative alpha tail? This is positive. You just mentioned, one of you just answered that tau is positive. So if delta E is positive, will alpha tail be positive or negative? The change in alpha tail. Positive, yes, exactly. So if I deflect the elevator down, the change in angle of attack at the tail is positive. This is why this point is true, right? So this sir has mentioned very clearly in the in his videos. You know it's represented by tau. This I had mentioned in my summary slides also. So this change in effective angle of attack at the horizontal tail due to elevator deflection. That is by definition, okay? Change in effective angle of attack at the horizontal tail, which is alpha tail. Elevator deflection, which is delta E. And what it's called is elevator effectiveness factor, okay? Now let's just do a quick revision, which I really suggest you guys do by yourselves. So static stability is the initial tendency to go back to equilibrium. And when we talk about longitudinal static stability of an aircraft, it is the initial tendency of an aircraft subject to some disturbance. It's the initial tendency to come back to its longitudinal equilibrium. Okay. Aerodynamic center, I think at least by now you guys are clear because we discussed this, and I think one of the first questions was this. Okay. Now the equation for CM is CM naught and DCM by D alpha into alpha. And the only condition for stability is DCM by D alpha should be less than 0. What is DCM by D alpha? It's the rate of change of pitching moment at the CG due to change of alpha. Okay. Okay. Now wing contribution. This is the wing contribution towards CM naught. This is the tail contribution towards CM naught. This is the wing contribution towards CM alpha. And this entire thing is the wing tail contribution towards CM alpha. Okay. Now let's just go over each term here because people seem to be forgetting some terms. Let's just revise. What is CMAC of the wing? Where does it come? And what are its typical values? What is CMAC wing? . What is CMACW? What is it like? What does it mean? Pitched aerodynamic center. Yes. It's negative for a cambered airfoil, positive for a reflex airfoil, and 0 for a symmetric airfoil. Okay. To know why they are, just go over the week 1 and week 2 contents. Okay. CL naught. What is CL naught? What is CL naught? CL at zero angle of attack. Correct. XCG is the location of CG. C bar is the mean aerodynamic chord. XAC wing is the location of aerodynamic center of the wing. CL alpha. What is CL alpha? No, no. What was CM alpha? We just discussed. CM alpha is DCM by D alpha. So CL alpha is DCL by D alpha. It is not the CL at a given. Question was, what is CL alpha? It is the slope. It's the lift curve slope. CL alpha is DCL upon D alpha. So if you were not clear about all of this, you people should have asked, okay? But we'll just go over those notations. CL alpha is the slope. CM alpha is the slope. This is CM alpha, right? Similarly, you have CL alpha, all right? Okay. Now VH. What is VH? What is VH? So please, I'm saying again, if there is any term, any notation that you are unsure of that you see on the slide, please do ask me. Okay, so this is the beginning. So you can clear all of your doubts now. And there are going to be a lot of notations that come later on, which may become confusing if you don't clear this. Any small doubt, any small question in your mind, please do ask me. Okay, so CL alpha is the slope. CM alpha is the slope. Now, what is VH? We had found this VH in some of the questions, so this should be simple. What is VH? Volume ratio of the horizontal tail. Perfect. CL alpha tail is the slope of the lift curve slope of the tail airfoil of the wing. There's an eta there. What is eta? What was eta? What was eta? Okay. So eta was the tail efficiency factor, which is V infinity tail square, V infinity square. Okay. So due to this downwash, there is a reduction in the velocity seen at the tail, which is this V infinity prime. Okay. So the ratio of the squares of the velocity at the tail and the velocity at the wing is the tail efficiency factor eta. Okay. Is that clear? Okay. IW. What was IW? What was IW? What was IW? Wing angle deflection. Can you explain what you mean by wing angle deflection? I'm sure your understanding is right, but so it's called wing setting angle. Okay. So it's the angle at which the wing is mounted on the fuselage, not when it's deflected, like at which angle it's initially mounted on the fuselage. So if this is your fuselage reference line and this is your wing, this is that wing setting angle. If this is fuselage reference line This is your I wing. Okay. Okay. So what is epsilon naught? Epsilon is downwash angle. It is expanded as epsilon naught plus d epsilon by d alpha into alpha. Okay, so the epsilon naught comes from there. What is IT? What is IT? Tail setting angle. Perfect. Yes. So it's the angle at which the tail is mounted on the fuselage reference line. Okay. VH, CL alpha. Okay. So I think all other terms are fine. Let's go to the next equation. Neutral point. Okay. All of these are fine. Okay. X bar NP is the location of the neutral point. Okay. Yeah. So here again, everything should be fine. What is ST? These are just a summary of all the formulae that we used. Okay, so if you just want to go over this, do go over it and let me know if there is any question. So what is ST? S or ST? Can someone tell me what it is? Tail area, exactly. S is the wing area. Okay. LT is the tail moment arm, which is nothing but X AC tail minus XNP. Okay. Sorry, XCG. This is LT. Okay. Everything else should be fine. Okay. This is the slide for the summary of the controls. Controls, what do control surfaces do? They just trim at a different CL. Okay, that's what they do. So they don't change the slope of the graph. So if you're CM versus CL, will the graph have a positive or negative slope? This CM versus CL. For a statically stable aircraft, will the graph have negative or positive slope? This is CM and this is CL. Negative, perfect, yes. So it'll be something like this. Now, what is trim? Trim is when the summation of forces and moments are 0. So in this case, this is trim. Now, if I want to trim it at a different angle, suppose I want to trim it here, I deflect my control surfaces so that the graph moves here. It doesn't change the slope of the graph at all, although my drawing is very crude here. It doesn't change the slope of the graph at all. It only changes the intercept. The CM naught value is changed. All right. So that is what control surfaces do. They do not affect stability in any manner. Expect such questions in your exam. Questions like, if I deflect the elevator, if I deflect the elevator down, how will the stability change? It will not change. Elevator is only for control. It's not for stability. Okay. Okay. Now, this is the convention. Elevator down is positive. What happens is that the zero lift line changes. What does this mean? When I deflect, so initially your tail is like this, and now when I deflect the elevator down, it becomes somewhat like a cambered airfoil, right? Why? How is a symmetric airfoil different from cambered airfoil? Your zero lift line changes. So this is your CL versus alpha for symmetric, and when I deflect the elevator down, it becomes a cambered airfoil. It becomes like this. Okay. This is what the deflection of the elevator does. It does not change any slope. Okay. Now, deflection of the elevator down produces a positive lift. Hence, your CL delta E is positive. Deflection of the elevator down produces a pitch down moment about CG. Hence, your CM delta E is negative. CL delta E is DCL by D delta E. And CM delta E is DCM by D delta E. Delta E is the elevator deflection. Okay. Now, tau is the control surface effectiveness parameter, the dou alpha tail by dou delta E, which we just discussed. Okay. Next, he had discussed this equation. So now let's draw this graph. Delta E trim and CL trim. Now we know CM naught for a conventional aircraft is positive. CM delta E from here we know it's negative. So the intercept, the whole intercept is positive, which is what is seen here. Okay. Okay. Next, you have X bar NP, X bar CG, which is positive for a statically stable aircraft. And your Cm delta E again from here is negative. So this entire thing is negative, which is why we have a negative slope. Okay. So now, where is this equation used? Suppose the pilot wants to trim the aircraft at a particular CL trim. So he'll plug in the value here and it will return how much delta E he has to deflect. Okay. Okay. Now let's see a few questions. Which type of propeller configuration gives less longitudinal stability of the aircraft? Pusher or tractor? What is pusher or tractor? What is the difference? Which is pusher, which is tractor? So this is your fuselage reference line. One is where the propeller is mounted ahead. One is where the propeller is mounted behind. Okay, so this is the CG. Which one is a propeller? Suppose which one is pusher? Which one is tractor? This is 1 and this is 2. Is one pusher tractor mounted on nose? Perfect. Yes. So this is tractor and this is pusher. Okay. Now both of them produce thrust, right? So propellers produce thrust. Now, if it is at an angle of attack here, because of the oncoming velocity, it also produces lift forces. Both of them. Now this tractor lift, so let's just call it tractor and this is pusher. LT produces pitch up or pitch down at CG. The tractor lift produces pitch up or pitch down at CG. Let me just erase this. So this is, one is tractor and this is pusher. There is a lift produced here and there is a lift produced here. This is L1, this is L2. L1 produces pitch up at CG or pitch down at CG. What kind of moment is produced at CG? At least tell me clockwise or counterclockwise. Pitch up, perfect, yes. So it produces pitch up, positive moment, which is not a restoring moment. Okay, so tractor does not give you longitudinal stability. What about pusher? It gives you pitch down. It gives you longitudinal stability. So what is the right answer here? Which type of configuration gives less longitudinal stability? Less longitudinal stability. The tractor gives you pitch up moment. We require pitch down. We require Cm alpha to be negative. Which one gives you less longitudinal stability? So tractor gives you Cm greater than 0. Pusher gives you Cm less than 0. Exactly. B. B is the right answer. So pitch up is positive, pitch down is negative. I hope that's ingrained in your minds. Pitch up is positive, pitch down is negative. Okay? Okay. Next. In an aircraft, the size of the elevator is decreased, keeping the vertical tail volume ratio constant. How will this affect the longitudinal stability of an aircraft? So size of the elevator is decreased, but your vertical tail volume ratio is constant. Okay, it should be horizontal tail. It should be horizontal, my bad. Okay. How will this change? How will the longitudinal stability of the aircraft change? So this is the tail contribution. Only this part contributes towards stability. This is Cm alpha contribution of the tail. Okay. So now tell me, In this equation, what is the horizontal tail volume ratio? What parameter shows this value? What parameter shows this value, horizontal tail volume ratio? What is horizontal tail volume ratio in this equation? We just discussed this. VH, thank you. Thank you, VH. So they say VH is constant. So now can you see the size of the elevator anywhere in this equation? I had just mentioned that the elevator does not contribute towards stability in any way, shape, or form. So what is the answer to this question? Yes, yes, remains same. Change in the elevator area, change in the deflection of the elevator, change in the shape of the elevator. None of these have any effect on the stability. As long as they said the horizontal tail volume ratio remains the same, the stability remains the same. Okay. The only contributors towards stability as far as tail is concerned is VH, eta, CL alpha tail, and the downwash slope. Nothing else contributes towards stability from the side of the tail. Okay. Okay. The static longitudinal stability of an airplane is provided by, it should be fairly simple now. What's the right answer? What is the right answer? Yes, yes, V, horizontal tail volume ratio. We just discussed this. This is VH. Okay. Next question. The position of the neutral point of an aircraft is 0.5 meters from the leading edge of the wing. So let's just draw this. This is your fuselage reference line. This is your wing. This is the leading edge of the wing, which is usually the reference from which we measure the CG, neutral point, AC, everything. Okay. So this is the leading edge of the wing. And they said that the neutral point is 0.5 meters from the leading edge. So if this is your neutral point, this is 0.5. Okay. And the location of center of gravity is 0.4 meters from the wing leading edge. Okay. So if this is CG, this is 0.4. Now, first of all, is this aircraft stable or unstable? Longitudinal static stability, is this stable or unstable? Okay, Sanath, you need to stop asking me if it's right. Be sure of your answer. I think even the previous question you were like, was it B? Don't be unsure. Is it stable or is it not stable? Sanath, why do you think it's stable? And why do you have a doubt? CG ahead of NP. Yes, so it is stable. Why did you have a doubt? Please don't have any doubt. Any question, do ask me. Is there any question as to why it is stable? Why it's stable? You had stable na question. Do you have any doubt? Why was there a confusion? Is there any doubt? Do ask me. You don't have to confirm, just be sure of your answers. Okay, so CG ahead of neutral point is obviously stable. Okay, let's move on with the question. The location of aerodynamic center of the aircraft from wing leading edge in meters will be. That is the question. Location of aerodynamic center from wing leading edge. So from here, how far is the AC? AC of the aircraft. Aerodynamic center of the aircraft. Y.4. You'll have to explain your answers. Y.4, Y.1. Let's start with Kanna's answer. Y.4. 0.4 is where the CG is. So why did you come up with 0.4 for AC of the aircraft? I just want to understand the thought process of why you came to 0.4. Just type it up or like tell me, or I just want to know from where it came. Why 0.4? You can also tell me if it was just random guessing. Okay. I thought it was AC. Oh, all right, all right. So no, it's CG. CG of the aircraft is at 0.4 and neutral point is at 0.5. They've asked you AC of the aircraft. Okay. The next answer was Harshit, says 0.1. Can you tell me why 0.1? Again, I just want to know the thought process. Like, why did you think it's 0.1? So 0.1 from leading edge means somewhere around here, right? So why here? Can you tell me what was your thought process behind it? Why 0.1, Harshit? Just type it down, or you are a big fan of unmuting yourself, so try that. I just want to know how you came to that, and this is the thought process. You can also tell me if it was just random. Okay. Anyone else? Any other answer? Because Harshit seems to have no reply. Okay. Anyone else? Any other answer? What is aerodynamic center of the aircraft? Can someone tell me? So we just discussed what is aerodynamic center. In the beginning of this class, middle of this class, we discussed what the aerodynamic center is. Can someone tell me what the aerodynamic center is? Just definition of aerodynamic center, plain definition. If you don't remember from the lectures, at least Google it and tell me what is aerodynamic center. Yes. The point at which pitching moment is independent of angle of attack. Perfect, Sandra. Yeah. So what is the aerodynamic? Okay, now tell me what is the definition for neutral point? So AC is the point at which pitching moment is independent of alpha. What is neutral point? Definition of neutral point. What is the definition of neutral point? Sandra, I think you can get it. We had discussed this and I think you will be able to get it. You're somewhere there. What is neutral point of an aircraft? Point where aircraft is neutrally stable. All right, but okay, that's valid. But neutral point also at 0 point. What does that mean? I'm not sure I understand what that means, Krishna. I didn't understand what that means. What is 0 point? Krishna, can you just try to tell me what 0 point means? I'm not sure if I missed something. What is 0 point? What is 0 point? Okay, I asked you what neutral point is. You're telling me it's the neutral point. What is neutral point? What is the 0 point neutral point? What is the definition? So Sandra says it's the point where aircraft is neutrally stable. Yes, it's right. By definition, I think, where was this? In the revision slides, it should have been there. Yeah. CG location at which CM alpha is 0. What does that mean? CM is independent of alpha. Yes, Sanath, you're right. Absolutely. So, yes. So Sanath says CG, or the point at which CM is independent of alpha. So isn't the definition of aerodynamic center neutral point the same thing? So I had mentioned this in both those weeks previously. Neutral point is not, so aerodynamic center is with respect to a wing. Neutral point is the aerodynamic center of the entire aircraft. Okay. So neutral point is the aerodynamic center of the aircraft. So now can you tell me what the answer is? Point 0.5. Perfect. Correct. So did everyone understand why it's 0.5? Is there any question? Did anyone not understand? Neutral point is the aerodynamic center of the aircraft. Both the definitions are the same. Just look at it. I know two different people answered, but it's the same. Definition is the same. Point at which the CM is independent of alpha, or where CM alpha is 0. Both of them. Neutral point is the aerodynamic center of the aircraft. Okay. Is there any question? Any doubt? Okay. Let's go to the next question. In-flight measurements of neutral point. At neutral point, your D delta E trim and DCL trim, that graph that we just saw, delta E trim and CL trim. Okay, this was the graph that we saw, and the equation was, if I have the equation somewhere, this was the equation. I'll just write it down again there. Delta E trim is CM naught by CM delta E plus X bar N2 minus X bar CG by CM delta E into CL trim. Okay, this is the graph and this is the equation of the graph. So now tell me, at neutral point, what is the slope? Slope of this graph is given by this value. Correct? This is the slope. This is D delta E trim by DCL trim. At neutral point, what is the value of the slope? Just use the equation and tell me what is the value of the slope at neutral point. Negative. Okay. It's usually negative. The value of the slope is negative. I understand for a stable aircraft, it's negative. At neutral point, your CG is NP. So this becomes 0. Correct? Numerator becomes 0. So what is the slope? Yes, correct. 0. The slope is 0. So we had discussed this again in the previous class. So if something like this is CG1, this is CG2, this is neutral point. Where in the fuselage the reference line, this is CG1, this is CG2, this is neutral point. As your CG moves closer and closer to neutral point, the slope keeps reducing until it becomes 0, as you can see from this equation. Correct? Is there any doubt here? So I had another set of questions to be discussed, like based on one value. I don't think I have time to complete that. So we'll discuss that in the next class. Does anyone have any other questions from whatever we discussed in the 3 weeks or today's class or anything? And please go back, revise, look at each term, each notation. If you're unsure, put it up on the forum or ask me next week. Do you have any other questions? If not, we'll end the class here. Do you have any questions? How to prepare for examinations? Go back and revise your notes. There are several things that are still ambiguous in your minds. Please go back and see those notations, see those terms. That's how you prepare. I don't think any of the questions were beyond what was taught, right? It was from whatever was taught and whatever was dealt with in the previous weeks. So the questions were fairly simple, right? Just go over, revise, at least see the summary slides and ask on the forum. Any other questions? Okay, if there are no questions, I think we'll end the session here. Thank you all. Very good luck for your assignment 3, and let's meet again next week on Tuesday to discuss those questions. Okay. Thank you all of you. Please go revise the contents. Thank you.